Formula Parser Demystified. Today we're going to be looking at envelopes. And before we begin, I'm just going to give you 3 examples, and you'll be able to do this by the end of the tutorial. So that's going to be really cool. You're going to have a lot of fun. Today's going to be a lot of good information here. Okay, number 1. So it's kind of like opening up you can hear bright tones starting to emerge, and we'll be doing that. Okay, number 2 is like number 1, but it's going to come back in on itself. It's going to open and then close. Okay, that's number 3. Now number 4 is like the first 2 but sped up, so I'm going to teach you how to do that. And this is without using a filter at all. You're doing it all mathematically, so I'm not even using the cutoff. Normally I would use the cutoff to achieve that, but I'm doing that all mathematically, which gives you a lot of flexibility. And as you'll see, you're going to be able to do a lot of things with that beyond what I've just shown you. Okay, good. So those are the 3 examples. Let's start out. What is an envelope? Let me go over to my graph over here. I have 3 examples I'm going to show you. The first one is 1 over cosh of x, or we could say hyperbolic cosine. The h is the hyperbolic, the cosine. So I could explain it to you. I don't want to do that today. I just want to get kind of into it. Just know that when you type this in, like you go 1 over cosh, you'll get that graph. I could explain it next time or at some point if you really want to know, but just get used to that. Get used to the terminology. The next one is another shape, e to the negative x squared. The next one, this is another envelope, e to the negative absolute value of x. So that's another one. There's tons. I mean, there's probably, who knows how many there are. I could think of a couple more. But we're going to do this one today, 1 over cosh, because it's easier to work with in a lot of ways. Okay, so now we're going to add to this. So we're going to do this. We're going to go 1/2 of x instead of just x. So notice how by adding the 1/2, we've slowed down the slope. So it's almost like we're slowing this x by half. And if I did a third, I would be slowing it even more. If I did a fifth, I would be slowing. If I did a 50, I didn't mean to do that, but now look how the slope almost stays in one number for a long time. It almost doesn't even go down. It's barely noticeable. So 1 over 5 gives you that. So that's the first step. Okay, now the next step is kind of cool because Serum only starts at 1. It doesn't start at 0 because there's not like a 0 frequency. There's like the first frequency. So what do we do? How do we do that? So what we're going to do, we're going to go parentheses around the x, and then we're going to go -1. And that moves this whole, function. You could call it function if you want. Envelope, I guess, shape. That moves over 1. So now we could have done like x minus 5. You could do that, or x minus 9. Alternatively, I could go in the other direction, but for Serum, it's not really that important. I could do x plus 7. It goes to the left, or x plus 3, or x plus 1. We'll go over to the other side. But for our purposes, for Serum, we're always going to be on the right side because we don't really have any negative frequencies. We only have positive frequencies. So I could explain why it's x minus 1 versus x plus 1. but I think you get the picture. If it's 1, that makes sense. If it's 3, it's kind of in the third position. If it's 5, that's easy to see. You could see it along the x-axis. You see the 5. Okay, x minus 1. Okay, so this is kind of like the formula that we're going to use. Now let's go back to Serum. And now let's type in that equation right in here where it says enter formula. And you could just start from scratch. Why don't I do that? So I'll just init preset. Start way from scratch. Let me add some reverb. And I'm just going to... Oops, wrong one. This is... Okay. So now we're going to enter the formula 1 divided by cosh. Now we need another parentheses, 2 in a row, q. Instead of x, Serum, you use q because we want to put, you'll see in a second, q minus 1, closed parentheses. And let's see, divided by, well, actually, let's do it this way. Well, there's a couple ways to do it, but let's start with the 1/5 times q minus 1. 1 parentheses, 2 parentheses. All right, there you have it. So there's this envelope right here. This is the shape of the envelope. Let's see what it sounds like. All right, so now what we're going to do is let's adjust this number. So let's do a half. So it got a little bit darker, and the reason why it got darker is because now we're not letting the frequencies pass. We've lowered the slope. So if I just did 1, we would lower the slope even more. That's just the regular cosh, just cosh without, I don't have anything in there. I just have cosh of x. So that's really not going to let a lot of the, it really only, you could only 1, 2, 3, 4, 5, 6, 7, 8, maybe 8. It lets 8 of these frequencies through. But now we're going to go 1 over, let's see 1 over 20. Ooh, that's really bright. Now all of these frequencies are coming through. So it goes up to like 90, probably even more than that. I can't even, at least 90. So maybe not that much. Maybe we'll do 10. All right, so 1 over 10. So by changing this number, you could, by making it bigger, by making the 10 bigger, you could brighten it up, or you could darken it by making this smaller. So if you said 1/2 or 1/3 would be a little darker than, like, let's say 1/25 would be really bright because you're. So I hope that makes sense. If you have any questions, just put them down in the comments section if you're like not understanding anything, because it can be pretty confusing. Okay, so now we're going to do something really cool. Instead of just typing in these numbers, I'm going to automate it for you guys. So in Serum, let's first start out by putting a parentheses around that. And we use Z to kind of automate, because Z is like a number from 0 to 1. It like scales through that number. So like in my graph, let's see, if I was in my graph and I did in Desmos and I put Z, let's just put Z for there. Z, notice that when Z, notice how the slope gets bigger. So I'm just scaling through. It's like automating it. Now I could just hit the play button. Do you see how the slope goes up and down? So it's going up, it's going up, it's going up, it's coming down, it's coming down. So that's what we're going to kind of do. We're going to do that. But since Serum only goes from 0 to 1, so it goes like this. It really doesn't go very far. It goes from 0 to 1. That's it. But there's what we're going to do is we're going to say like 20 times. So now watch. So now it's going to be 20 times that. It's going to really go. So Z times 20. So it's going to go to that, this, whatever this is. This is the, think of 20 as the height, what you want to go to. So let's see. Let's see what that sounds like. What happened here? Oh, I didn't turn on the wave. So basically, here's this wavetable position. So we're going to move that there, this LFO, and we're going to take this LFO right here and move it onto the wavetable right there. And we'll slow that. We'll go, you could do either BPM, because what that does is it attaches itself to your DAW tempo, or we could just do hertz. Do really slow. How about there? So now, oops, and I forgot to do the trigger. So this, when off it goes from any point. It doesn't re-trigger, but I want to trigger this so it always starts at the beginning. So that's pretty cool. So now you just like made a wavetable of Z it goes from 1 to 20. It basically it kind of goes like this. Think of Z as, here we have think of Z as X, this line. And right now, Z goes from 0 to 1. But since we did 20, we made this line very steep. So in 1 second, it's going all the way up to 20 right there. So that's what we're doing. That's in 1 second, we're going all the way up to 20. Let's say we go up to, let's say we want to have like 40. So that's all the way. It's going to open up all the way to 1/40, 1/40th of X. That's very slowing down that slope. So it's almost not, if I wanted to, I could even do 1/400. It's going to get so buzzy. It's almost like these frequencies go all the way to 1 almost at some point. So you play around with it, 15. That's kind of cool. Notice that it goes to the top, and then when it finishes, it drops back down. It goes up, 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 and then it drops back down. So what are we going to do now? We don't want to necessarily, let's say, okay, we want to do that for now. But let's say we want it to come back down. So it goes up and comes back down. So what are we going to do? Okay, let's go back over to here. And you're going to learn another function now. And this is a very useful function. It's called the sine function. And it looks really cool. It's like a wavy function like this. And so the filter let's say, I'm going to teach you to attach this to that, to the other thing we did. It's going to open up to there, and then it's going to come down and go back to where it was. So this is a very useful function, sine of X. Okay. Now, I'm going to put this, maybe some of you have heard the pi, like a circle. It has 360 degrees, and 2 pi is a full rotation. I don't know if you remember that from class. But so what that is a full rotation is like a full cycle is up from here all the way up, down, back down, and then stops here. This is a full cycle. But so So we will, for Serum, we don't have negative frequencies, so we're just focusing on 0 to 1. So that's all we care about. So that's why I didn't do 2 pi. If I had done 2 pi, I would have had 2 pi as 1 cycle. So if I had 4 pi, that would be 2 cycles in 1 second. So 1, and then 2 in 1 second. Or 6 pi would be 3 cycles in 1 second. Or 8 pi, 4, and so on and so forth. But we don't even, we're pi. We're doing a half a cycle in 1 second. If 2 pi is 1 cycle, 1 pi is half of 2, right? 2 pi, half is 1, half of 2 is 1. So anyway, I hope that wasn't too confusing. But I think it's good to know what you're doing and not just putting formulas. I know a lot of people, they just copy and paste formulas. They don't know what the heck they're doing. So it only gets you so far. You're only going to get at some point. If you really know what you're doing, you could just take it as however far you can go with it. So, okay, so we're going to embed this sine function in that. I'm going to show you how to do that. So, in fact, okay, so let's go, okay, one more thing. If I did put a 5 in front of this sine like this, I would be 5 times the size. That's what we're going to do. We're going to go, it's at 1 right now. And if I do 5 times 1 is 5. Or 10, I can make this sine wave stretch out really high up to 10. And then come back down to 1. Okay. So this is what we're going to do. Just so I'm going to do it here really quick. We're going to, instead of z, we're going to put sine right here. A pi times z. And we're going to put it under there. And then we're going to do 10. So now watch what happens. Oh, there we go. But maybe I won't do 10. Maybe I'll do 5. Oh, not 50th. 5. So you can see it's just going back and forth. It's kind of doing this thing. It's going up and down. Opening, get to the top. Now coming down. And now repeating that. Open, closing. So we're using the sine to open and close this. We're like the z, but we're doing it in another way. Where instead of going up, we're using z. So let's add that to our function. Okay, so now I'm going to type 10 is how high. Where do we want the end point to go? Like 10 is our end point. 30, let's say 30 times sine, parentheses, pi, times z, close parentheses. And let's see. Oh, I think we're going to have to do plus 1. The reason I did plus 1 is we don't want 0 because we want to start right. We don't want to start from like, let's see what happens if I do 0. It starts from here. It starts from nothing. Here I just put 1. So it would start at the first. It wouldn't start because Serum doesn't start at 0. So that's why I just put the 1 right there. So there you go. And so we could play around with that if I did 10, let's say 10. I want that to be my maximum point, 10. So play around with that. You could do 200, 100, figure out what you like. Okay. So, okay, let's see. I'm figuring out whether we should that's a lot for today, I think. So in the next video, what we're going to do is I'm going to show you how to speed it up. So we have this certain, let's say if I was doing BPM 1 bar. So how could we speed this up so maybe we have 2 cycles in that bar instead of 1 cycle. So right now it's just one open and close in 1 bar. But next time, I think once you get this, I'm going to go ahead and speed it up, show you how to do that. Because that's a bit of, there's a little bit more there, but I think this is enough for today. So, okay, let me give you just a little preview of maybe the next couple lessons, what we're going to be doing. And it gets really exciting. It really gets interesting. Now from here, take a look. Once we take what we've learned, you could have you have some really cool pulses you could do. You could do a lot of different things. You could have like a big pulse and then a smaller pulses in that. So I'm going to teach you how to do that. And then this is another cool thing. Maybe in the next couple, this is taking this idea, but now a completely different sound. So it's a more metallic sound. Sounds like the aliens are about to come. So that's a little bit more advanced, but the same idea of opening the filter. What you learned today is exactly the foundation of everything we're going to do beyond this point. So learn that. I hope this helped. I hope you enjoyed it. Have fun with that. And I'll catch you in the next video. Okay?